Welcome to lesson one of History of Economic Thought. In what follows, you will apply modern economic models to study ancient economies and their policies governing the production distribution of goods. Although former economic theories, such as supply and demand, were absent in antiquity, these models provide robust frameworks for simulating historical behaviors and evaluating their outcomes. Your task is to use these tools to examine how economic decisions in ancient societies, shaped by trial and error, tradition, religion, or royal authority, affected output, political legitimacy, and societal stability. Approach this as a historian equipped with an economist toolkit, connecting ancient decision making to analytical methods used by modern economists and policymakers. Ancient Babylon's economy was primarily an agrarian barter system, relying on the direct exchanges of goods like grain, livestock, and oil, or other recorded equivalents. Temples and places acted as key economic hubs, managing debts and distributing rations using standardized units, typically based on barley or workdays. Watch the video below to humorously discover how barter systems functioned and why they are inefficient. In this part of the lesson, you apply this formula here to calculate this answer, this answer, this answer, and this answer. The other numbers should be evident when you get into it. And words that go into here, here, or here are obvious from the context of this problem or from the video itself. If you're unsure how to proceed here and you can't find the answers from the video or from the text, please come to my office hours and we can discuss it there. Now, the transition from barter to a monetary economy in Babylon was marked by the adoption of silver-based money, specifically unminted silver pieces known as shekels, typically weighing around 8 grams. Silver served as a universal standard of value for contracts, wages, and legal settlements. Barter could still be used to exchange goods, creating a hybrid economy. The system enabled greater market integration and economic efficiency. To promote order and fairness, especially during times of scarcity, Babylonian rulers enforced strict price and wage controls. The legal code set fixed prices for key goods, wages for various types of labor, and maximum interest rates, reflecting a commitment to social stability and protection for debtors, tenants, and workers. In a climate-sensitive agrarian economy, droughts could cause severe shortages. In such cases, the state released stored goods from royal or temple warehouses to stabilize supply and maintain mandated prices. During times of abundance, the state collected taxes in kind, typically grain or barley, which were stored to prevent market gluts and ensure reserves for lean years. This policy smoothed price fluctuations and maintained economic balance. The integration of silver as a unit of account with centralized surplus management reflects a key development in Babylon's institutional economic framework, a blend of market mechanisms with strong state oversight aimed at preserving social and economic stability in an agricultural-based society. Black markets likely existed in ancient Babylon, though direct evidence is limited. The strict price, wage, and interest controls imposed by the law created incentives for illegal trade, particularly during times of scarcity. When droughts or poor harvests led to shortages of essential goods like barley, some sellers and buyers would have been motivated to bypass government mandates and engage in off-the-books exchanges at higher prices. Such underground activity also helped people evade taxes or temple dues tied to official transactions. Now, we know that was probably going on because there were laws against it. Enforcement was likely uneven, especially in rural or peripheral areas. Though it's impossible to quantify, black market activity was probably small relative to the formal economy, which was anchored by palace and temple institutions. However, during periods of economic stress or administrative weakness, the scale and importance of black market commerce likely increased, filling gaps that the regulated system could not address. Now, the video that I'm making will be placed here, and you'll pause and play and pause and play to work your way through the answer to the question. And your version is going to be different than my version. You can see that right here. If you look at your demand equation, I got price on the vertical axis, I got quantity on the horizontal axis. I got the y-intercept or the price intercept. This is the value of price when the quantity is zero. And then the slope here is negative. So this is the demand curve. And this is the supply curve. Generally, as prices rise, more and more people want to supply the good. So that's the law of supply. The law of demand is, generally speaking, as prices rise, people buy less and less of the good. Copy these two numbers and the subtraction symbol into Desmos here, which I've opened up already. I clicked here, open up the website, and then placed it to the right of the actual problem. I'm going to copy these two numbers with plus in between and paste that right here. My demand and supply curve shift around a little bit when I update the Desmos model with numbers in my model. Now, to find the quantity of barley that is supplied by farmers and demanded by consumers, you'll use your Desmos model over here. To find the equilibrium price and quantity, you just click on the intersection point. And the quantity here for me is 326. The units are in Sila, a Babylonian unit of measure equal to about 1.4 pounds. So this is probably around 300 pounds of barley. This is a lot of barley because last Christmas break, I bought a 25-pound bag of red hard wheat from a farm in Palouse, Washington. And there's probably enough wheat in there after I grind it into flour right before I put it in my bread machine to make maybe 2 weeks worth of bread if I make it every day. So this is a lot of barley. Now, to find the market clearing price, click the intersection of the lines in your version of the model, like I did. And the price here is 0.189. Highlight the number and then press Control-C on a PC or Command-C on a Mac to copy the value. And you can paste it by doing Command-V, as in victory, or Control-V, depending on what kind of computer you have. And you can press Enter to see if you got it correct. And I got both the answers correct. Now, again, the weight is in Sila, which again is about 1.4 pounds. The price is in jins. The jin is to the shekel what the penny is to dollar. 1 jin equals about 1/60th of a shekel, whereas 1 penny is 1/100th of a dollar. 1 jin in ancient Babylon is roughly $5 today. Now, this is at a time when you didn't go to the grocery store and buy bread. You had to grind the grains, the barley, the wheat, whatever, to make your food. You had to grind it. It was hard and you had to grind it every day. So making food back then was very labor intensive. Now, regarding the first sila of barley supplied, the first 1.4 pounds, we need to find the maximum price the first consumer could pay. Now, you can think of the first consumer as the king or the king's brother or the king's top advisor. They're going to be the wealthiest in society, and they're going to have the most income and therefore the highest ability to pay for barley. So the way you're going to get the maximum price of this first consumer is to change x equals 0 to x equals 1. Remember, x is quantity in our model. And you can't see it, but there's a vertical line there. See that vertical line? So we're going to set the vertical line at x equals 1. And then we're going to click on this gray dot. And notice the first number here is 1. That's talking about that first pound of barley. How much is the wealthiest person with the highest income willing to pay or able to pay for that first pound of barley? If things are really scarce, poor people aren't going to be able to pay the same price as some rich dude. So a rich dude's going to be able to outbid the poor. So again, you can highlight the price and then press Control-C or Command-C. And we're going to put that right here. I'm going to press Enter to make sure I got it right. Now remember the welcome video. I mentioned you only get 2 chances at each answer box. If you get these answers marked wrong, make sure that this number matches that number and this number matches that one and that the slopes match too. Then if you got this correct and that correct, but you got this incorrect, make sure when you click on this dot, the first number is 1. The second number is the price. If you do that, this should be a pretty straightforward, easy problem to do. Now, what about the minimum price farmers are willing to accept? Now, you got to think about a farmer. A farmer like my dad, at the end of the season, when he harvested his potatoes, he had a ton of potatoes. He had a super abundance of potatoes that he hadn't sold yet. They were sitting in his warehouse. And he'd tell his people, his workers, hey, it's okay, grab a couple potatoes and take them home. He was giving them away for free. Why? Because he had a super abundance of them. So imagine a farmer with all this grain or barley they just harvested, and it's sitting in their barn or wherever they put their grain when they harvested it. What's the lowest price they're willing to accept for that first pound of grain? Wineries in California, what do they do with that first bottle of wine? Well, people go on these winery tours. They have all this wine sitting in warehouses. When you go on these winery tours, they give away product for free. So when people like farmers or people who make wine have their superabundance before they put it on the market to sell, they have the superabundance of a product. The very first unit of that product, they will tend to give it away, like my dad or a guy that owns a winery. When you have this superabundance and you don't have money or you don't have any Babylonian wine, but you have all this barley, you need wine. They don't have other products that they need. They only have a superabundance of the product that they're growing and harvesting. So they have the superabundance. They're willing to give it away to get something they don't have. And so when people engage in trades, both the supplier and the demander gain in those trades. So what was the minimum price farmers were willing to accept for that very first sila of barley supplied? Well, now you got to go down on the supply curve and make sure this dot, again, the first number is 1, because we're talking about the first sila of barley supplied. And then we need to get the minimum price they're willing to accept. Now, it's not free, but it's really, really low. Now, what is the price that is paid for this barley? Well, the price that's being paid for the barley is the thing that you already put in here, right? The market price. The market price is determined by demand and supply, and it was 0.189. So if this farmer is getting 0.189 gins per sila of barley, but this farmer would be willing to sell it for as low as 0.0265 gins per sila, that farmer wins. And we call that producer surplus. The person first in line who has the highest willingness or ability to pay for barley, they're willing to pay up to 0.3515 gins per sila. But they only have to pay that amount. That person wins too. Both people win in this commerce. So to calculate the consumer surplus and the producer surplus, what we're going to do is we're going to take this value and we're going to subtract off the market price, 0.189 gins. And we get a consumer surplus equal to that amount. This is kind of how good someone feels when they buy something. If you go to a garage sale and you're looking to buy something like a desk, and you have an idea of how much you're willing to pay. Maybe you're willing to pay at most $80 for some used desk. And you go to this garage sale and you see one being sold for $90. Well, you walk up to the guy that's selling it, the guy that owns the house, and you say, hey, I'll give you $40 for that. You're willing to pay at most 80, and it's listed at 90. That guy might counter with, well, how about 60? And you counter with 70, and you agree at 70. You walked into that transaction willing to pay at most 80, but you got it for 70. So you gain $10 on that transaction. That's what we call consumer surplus. It's how much you would have paid minus what you actually paid. Same thing goes for the supplier. You were looking for that supplier's lowest price they're willing to accept. Only that supplier knows their reservation price. You were looking for it because you had offered that guy $40. Now, what you could have done is you could have said, when you offered 40 for it, you could have, and he countered with 60, you could have said, no, I want 40. And the guy may have offered 50, and you go, no, I want 40. And then he goes, how about 45? And you go, no, I want 40. And then he goes, how about 42? And then you agree at 42. You probably found the minimum price he's willing to accept. But you guys agreed to 70. So if the guy's minimum price he's willing to sell it for is 42, but he got you to agree at 70, that seller wins as well. You both win. That's why transactions occur. He's got something you want, and you got something he wants. He values the money more than the furniture in his garage. You have the money, he has the furniture. You value his furniture, you don't value that money as much as his furniture. So you get together and you agree on some price. And that price that you agree upon is the market price. And you have a maximum you're willing to pay, and he or she has a minimum he or she's willing to accept. And both people win in that. The free exchange of goods, services, and ideas is the tide, in my opinion, that lifts all boats. Nobody's coerced. It's all voluntary. And it happens today, and it happened back then. It happens in markets in Africa. When people sell goods in Africa at local farmers markets, they are doing the exact same thing. In some cultures, I discovered when I was in the Navy, if you didn't haggle on the price, it was taken as an insult. In America, we're not really used to haggling, so it just depends day to day. If you're driving around a town looking for the lowest price of gas, you're doing exactly what's going on in this model. You're telling all these suppliers of gasoline their prices are too high. And the suppliers of the gas are offering different prices because they have different minimums they're willing to accept. So when you drive around looking for the lowest price gas, you're doing exactly what this model is predicting. You got winners on both sides of the transaction. Now, to get the producer surplus, you want to subtract from the market price the lowest price the supplier is willing to accept. Regarding the second silo of barley supplied, you can think of the demand curve as a Q, a line from the richest or wealthiest consumer down to the poorest. The poorest is over here, can't afford to pay any price. This poor person can afford to pay a price, but is a lot lower than the market price. This person here is either the wealthiest person. When you're talking about wealth, this person has a bunch of previous incomes saved in some kind of account, or maybe back then it was a jar. In the book, my Perlos book called The Good Earth, the peasant farmer who becomes a wealthy guy, he saves his money by putting it in the clay wall of his home. So savings or wealth is just the accumulation of past income streams. So wealth is just, in its simplest terms, past incomes that weren't turned into consumption. They were saved. Wealthy people, then you have people with income, a professional that works for the king. The king gives this professional a salary for providing advice. Either the person has income or the person has past incomes that are saved up. And that one person is going to have the highest ability or willingness to pay. The second person line, the person with the second highest ability to pay, how are we going to find that? We're going to change x equal 1 to x equal 2. So the second person is willing to pay what? Make sure the first number is 2, and then you can copy the second one by doing Command C or Control C. The minimum price farmers are willing to accept for that second silo of barley is what? Again, make sure the 2 is here, and then you copy the second number with Control C or Command C. The price that is paid for it is 0.189 gins. The consumer surplus of the second silo of barley sold is the difference in that and the market price, which is 0.162. The producer surplus of the second silo of barley sold equals this minus the 0.027. So this is the market price. This is the price the farmer gets paid, and that's the price they would have been willing to accept to sell and produce that second silo of barley. Now, regarding the 265th silo of barley supplied, now I'm going to change x equal 2 to 265. And now you can see the consumer surplus is the difference in this height and the market price. And the producer surplus is the height here and the market price. Maximum price the 265th consumer could pay is 0.2195. The minimum price farmers are willing to accept to supply that 265th silo of barley is that value. And they're getting closer, aren't they? This is the maximum price the 265th consumers are willing to pay. This is the lowest price that farmers are willing to accept to supply the 265th silo of barley. They get the market price, which is 0.189. So now we're going to subtract this from the market price to get the producer surplus, which is 0.0305. Take this value here, and we're going to subtract from it the market price, and we're going to get the consumer surplus. Now, what about the 326th silo of barley? I'll first replace x equal 265, the 265 with 326. Does this 326 look familiar? Yes, it is the equilibrium quantity. We call this the marginal transaction, the marginal buyer and the marginal seller. If you're a marginal supplier, you're indifferent between selling that silo of barley versus keeping it. And the consumer is indifferent. They're indifferent between buying that silo of barley versus keeping their shekels or their gins. We have a mistake right here. 0.189. That's a good thing I have 2 attempts per box, right? All right, good. We got that fixed. Now notice it's locked. I can still change that, but I cannot change this. So I'm going to change this to 326. Notice the dashed line is at the intersection of demand and supply. So the most this person's willing to pay is the market price. Or the lowest farmer's willing to accept is the market price. At the equilibrium where the market clears, consumer surplus and firm surplus are both 0. The market is clearing at a quantity of 326 and at a price of 0.189 gins. This does not say that consumer surplus and producer surplus is 0. When you're looking at that one transaction, that last transaction, that is the case. But for every other transaction, the most consumers are willing to pay exceeds the price they pay. Farmers' reservation prices are less than the market price. I'm going to change this to 0.189. So I have this red line here, this upper triangle that's between the red line and the demand curve. The area in between is total consumer surplus. The area in the lower triangle below the red line to the supply curve, that's total producer surplus. These are the gains in trade that occur from these transactions, these voluntary exchanges of shekels or gins for silo of barley. And these are the gains that accrue to the consumers. So I have the gains that accrue to the consumers for engaging in these voluntary transactions. And I have the gains in trade that accrue to the suppliers. And together, when you add these two together, you get the total surplus. Now recall that Babylonian rulers enforced price and wage controls to promote order and fairness. At some point after the introduction of money, suppose the king set the price of barley at 0.22 gins per silo. So I'm going to change this to 0.22. By law, silo has to be sold at 0.22 gins. That year, the weather was ideal, producing an exceptional harvest. Farmers rejoiced as vineyards overflowed with plump grapes and olives, and fields yielded an abundance of barley and wheat. Government granaries filled quickly, and markets bustled with trade. The bounty not only promised full bellies and strong commerce, but also enabled the state to collect generous taxes in kind, ensuring reserves for any future lean year. In your Desmos.com model, modify the third equation, which I've already done. I've taken y and I've set it equal to 0.22 to implement the price control in your version of the model. Now, your value might be different, just like your demand curve and your supply curve are different than mine. The value here is going to be different in your model. Because it was illegal to sell a silo of barley at any price other than 0.22 gins, this value is that value because the king set it at 0.22 gins per silo. I'm going to press enter. Now notice that I have this flat line drawn in here. So what I'm going to do is I'm going to change the color of this line to blue to match. So this blue line matches that blue line. So typing that number into that box inserts that black line through our graph. What do farmers want to produce at this price? Well, at the previous market price of 0.189, farmers are supplying 326. If the price were 0.0435 instead, farmers would only supply 35. If the price were 0.108, farmers would supply 164. As the price comes up, more and more farmers supplying product in this market. When the price is 0.151, 250 silo of barley are supplied. At 0.22, farmers are willing to supply 388 sila of barley. Now, think about consumers. Before the price control, people were paying 0.189. All of a sudden now they got to pay 0.22. It's illegal for them to pay any price other than 0.22. They can't pay above 0.22 and they can't pay below 0.22. They have to pay 0.22 gins per sila of barley. So this eliminates people in the market. If each person buys one sila of barley a day to make their bread, then a lot of people dropped out of the market. There were 326 people in the market here. Now there's only 264 people in the market now, right? Because the price went up. So consumers are demanding only 264 sila of barley. The difference in these two quantities is called what? Let's calculate the difference. 388 are supplied, only 264 are demanded. So you have too much being supplied. That difference right there, that's how much the king purchases in the market to push the price up. This is how price supports worked in the 1980s for milk. If you read this article from the Cato Institute titled something like Milk Bootleggers, the New Illegal Class, it's a Cato article written about price controls in American agriculture back in the 1980s. The government wanted the price of milk to be higher. And they did it because they wanted to make sure that the family farmer survived. The only problem with that is when government drives the price of milk up, what do poor people do? What do middle income people do who can't afford the new higher price of milk? Well, maybe they turn to sugary things like Kool-Aid. And maybe that helps explain obesity in the United States. Now, the farmers loved it, but the consumers had a hard time buying it. My mom had a hard time buying milk in the 1980s. We got milk for free from the government. It was dehydrated, free government milk. We also got free government cheese. The cheese was great. The big 2-foot block of government cheese was awesome. It was cheese, cheddar cheese, right? But the milk was nasty because it was dehydrated. We had to add water to it to turn it into something we could drink. So we had a hard time buying milk. So government has been doing this for a long time. So what happens here, in order for the price to be at this higher level, 0.22, government has to estimate how much barley, in the case of this model, or how much milk in the case of the 1980s, to take off the market to push the price up. So the difference is 124. And so it's not a shortage, it's a surplus, equal to 124 silos. There's extra barley being grown. And the government has to confiscate that surplus to push the price up to the price that it wants in the market, 0.22. So this is something that governments have done for thousands of years. So the king here, in the form of taxes, confiscates 124 silos of barley. That's how the price is driven up to the king's price. 124 silos of barley go into government warehouses. It's taken off the market. This in-kind tax stabilizes the market by keeping the price fixed at the king's decree and assures that barley is available in times of famine. Famine was a constant risk in ancient agrarian economies, often triggered by natural forces beyond human control. Probably why ancient peoples worshipped thunder, lightning, rain, the sun. A solar minimum marked by reduced sunspot activity could lower the sun's energy output, chilling the earth and stunting plant growth. Massive volcanic eruptions could blanket the sky with ash, blocking sunlight and dropping temperatures, hindering crops. Shifts in the Atlantic and Pacific Ocean cycles could also disrupt weather patterns, pushing rains north or south and causing droughts that decimated agricultural yields. Suppose one of the above occurs. The result causes barley supply to do what? Well, if the weather is bad, yields are going to be lower, supply is going to decrease. By pressing enter or submit to enter this into the algorithm, it changes the supply curve. Now the supply curve used to be over here. The supply curve is now to the left of where it was. So I need to make that change in my model here. So to make the change in my model in Desmos, what I'm going to do is I'm going to copy the intercept and then change the value of the intercept in Desmos on the supply curve. And then I'm going to change the color to orange so it matches. So this is my new supply curve. This is the original demand curve. And this is the price control that is still set by the government. The government imposed a price of 0.22. Let's find out what happens when supply is affected by the weather in a negative way. Due to the king fixing the price of barley at 0.22 gins, that has not changed. It's still 0.22 here, right? What do farmers do? Remember, farmers are supplying barley to the market. They're now willing to sell it for as low as 0.1385 gin per sila. The wealthiest, or the person with the highest income in the kingdom, is still willing to pay 0.3515 for that first sila of barley. But the farmer now, a lot of the marginal farmers were eliminated, right? Maybe the famine didn't really affect farmers near rivers, but it affected the farmers further away from the river. So maybe the river still has water in it, and the farmers closest to the river are still able to grow barley, but the farmers away from the river cannot grow barley. So now maybe the barley growers that are able to grow barley when there's bad weather are willing to sell that first sila of barley for 0.1385. If the price were 0.175, 74 sila of barley would be sold. If the price were 0.2095, 143 sila would be sold and produced. But at a price of 0.22, the government set price of 0.22, 164 sila of barley are sold and produced. What are consumers demanding at this price, 0.22? Well, at this price, consumers are demanding 264. That hasn't changed. Remember, demand hasn't changed. We're holding demand constant. So that's still 264. Just the supply has changed. So we have the quantity that is demanded minus the amount that is being supplied, 164. A shortage. At this artificially low price, it's lower than market price. At this artificially set low price by government, 264 sila of barley are being demanded, but only 164 are being supplied. So we have a shortage in the amount of that difference. A shortage equal to 100 silas. Now the king needs to do what? To keep the price in the market at 0.22, the king needs to release an amount equal to the shortage, which is 100. The law back then strictly prohibited citizens from selling at prices other than those set by the king, with violations punishable by what? Honorary mention in temple records? I don't think you get an honorary mention in temple records. Rain dances and chanting? I don't think that would be a punishment. Extra barley portions? Well, that would be a reward. Complimentary bread rations? Well, that'd be kind of a reward too. Relocation to royal gardens? It's kind of a reward. Fines or even death? Well, that is definitely a punishment. Invitation to a king's feast? Well, that isn't a reward. So how do you make sure the law is complied with? Well, you have to punish people who do not comply with the law. And the only choice that makes sense is fines or even death. During times of plenty, the king's set price exceeded the market clearing price by what? Well, the market clearing price was 0.189, right? In my model, the market clearing price is 0.189. And the king set price is 0.22, right? In my model. Price is still set at 0.22 gins. So during times of plenty, the king set price exceeded the market clearing price by 0.031 gins. Because the highest price the 265th citizen could pay was what? We already answered that question. The highest price the 265th citizen could pay was what? 0.2195. Citizens from the 265th through the 326 could not buy the barley at the king's price. They didn't have enough income to do so. So to avoid hunger, let's reset the model though. I'm going to insert the original supply curve down here, and I'll change it to black. And I'll turn off this orange curve. Okay, so an original situation here, at the king's price of 0.22, if each person buys a sila of barley each day, then there are 326 people buying barley daily, right? If the price were allowed to be the market price, 0.189. But the king set the price at 0.22. Person 265 to 326 isn't able to pay the king's price. So the people that populate the demand curve just below this black dot here, 265th person, the 266th person, 267th person, et cetera, to the 326th person, all these people are eliminated from commerce when the king sets the price at 0.22. They're no longer able to afford the barley, right? So to avoid hunger, they do what? Photosynthesis is done by plants. They can't photosynthesize. They're not going to dance in celebration. I don't think they're going to petition the king for royal snacks. I don't think they formed a protest ban. I don't think they're going to try fermenting mud into soup. I think they're probably starved or they stole food. Price control leads to theft. People who are able to buy it at the market price of 0.189 in my model can no longer buy it at the king's price. So they're either going to starve or they're going to steal food. Now, during the famine, the market clearing price exceeded the king's set price. Let's turn off the old supply curve and turn on the famine supply curve. The market clearing price is up here now. The market clearing price is 0.245. And the king's price is 0.22. The bad weather, for whatever reason, killed crop yields and reduced the supply of barley. So the market clearing price exceeding the king's set price by 0.025 gins had what effect? This creates strong incentives for citizens to sell barley illegally. Why would people be enticed to sell barley illegally? Well, by law, they're supposed to sell all this barley at 0.22 gins. But the market price, people are willing to pay more than 0.22. Barley is scarce. Times aren't as easy as they used to be. Food is hard to come by. Rich people are having a hard time finding food. They can afford to pay more. They have the means to pay more. They either have the income or they have the past income in the form of current wealth. They're willing to pay more, so the market price is higher. This discrepancy created a strong incentive for citizens to sell barley illegally at this market price of 0.245. While all farmers, you can't say all farmers. All merchants, you can't say all merchants. No merchant, I don't think you can say no merchant. I don't think you can say no farmer. While a few farmers or merchants, so a few farmers, merchants, engaged in black market sales. A black market gets the name from the fact that it's not being done during the light of the day. Producers of barley, producers of wheat, producers of wine would sell in markets that were open when it was light out, and they were being observed by government officials. A black market is where this activity is being done outside the city walls in the night, or maybe out of your back door when it's dark outside. There's not going to be any light at night. So all these sales are probably taking place at night in alleys behind homes and whatnot. So that's where the name black market comes from. Scrupulous speculators and corrupt officials could exploit the price gap. And this is called an arbitrage. An arbitrage is where you buy something at some price. You don't do anything to the product. You buy it and you sell it at a higher price. So they're engaging in an arbitrage, an illegal arbitrage. Probably happened back then because there were laws against it. We know it happened because there are laws against this. So we have this arbitrage. A person is buying barley from the temples in Babylon and reselling it on the black market at the higher market clearing price. The harsh penalties listed in the law, the Code of Hammurabi, imply that black markets and crime are common. Now, suppose the quantity of barley in government warehouse is 5 times the pre-famine surplus. So the pre-famine surplus in my model was what? The king was confiscating 124 silos of barley. So in this table here, what's happening is in the year 1750 BCE, there's no famine. The pre-famine surplus was 124. It was 124 in 1749. It was 124 in 1748. It was 124 in 1747. It was 124 in 1746. After 5 years, the surplus in government warehouses is 5 times the pre-famine surplus. This number is 5 times that because we've had 5 years to accumulate this each year. It could be in millions of silos. It could be in billions of silos, right? The units don't really matter here. Now, in 1745, the famine starts. And what was the shortage in each year of the famine? Well, the shortage in my model was 100. So every year the famine persists, there's a shortage of minus 100. Right? So the orange years represents famine. The green numbers represent ideal conditions for growing barley. So what I want to do is I want to create a spreadsheet here, a very simple spreadsheet model. I'm going to copy a thing outside the table and everything within the table. I'm going to copy that to Excel because if you don't copy something outside the table, you can lose the table formatting when you paste it into Excel. When I paste it into Excel, I'm going to pick match destination formatting. Okay, so what I'm going to do here is I'm going to take the total amount of barley in government warehouses in the previous year. I'm going to add to it this negative number. If this number were positive, we go from 620 to 720. But the number is negative, right? Because we have the shortage during the famine years. We're going to find out when the government warehouses, in what year they empty. So then I'm just going to drag this down to the bottom. Now, where the numbers are negative, we can't have a negative inventory, right? I'm just going to make that 0. Okay, so we're in a lot of trouble in the year 1739 in my model, right? So after the first year of the famine, we have 520 silos of barley left. After year 2 of the famine, we have just 420. Remember, we're not adding anything to the warehouses. We're not adding anything to the government warehouses. We're subtracting from the government warehouses. And we're okay until the year 1739. In the year 1739 is when we have mass starvation because there's no grain left. Only the rich people are surviving. Only the rich people are surviving in the year 1739, 1738, and 1737 because this grain here is being supplied. This grain that correspond to points along this orange curve above the blue line are not being produced. Only points along the orange line to the blue line are being produced. And who can afford that? People with higher incomes or great wealth from saved incomes from past years can buy this food. I'm going to press enter to make sure that all my answers are correct. Looks like we're good to go there. Now we can answer this final question. The government warehouses will be depleted during what year? Not the first, not the second, not the third, not the fourth, not the fifth, not the sixth, but the seventh. In my model, it's the seventh. Yours might be different than my answer. By leaving these blank, I'm essentially inviting you to come to my office hours if you can't figure out the correct answers here. Okay? If you're locked out a lot of these questions down here because you used up your 2 attempts and your score is low, you can click get a similar question. Now, if you click get a similar question, doing so erases everything that you did. Lesson 1 is not done. We have a question called the Laffer curve, and then we have another question about the Joseph story in Genesis.